So there are 5 library functions that you need to memorize that we're going to be using both for the piecewise graphs that we're going to do in the next video and also later on for translations and other things. So the first one is y equals x, and you'll notice in this Desmos that I'm in, you don't put the y equal part. You just put what the right-hand side would be. So y equals x, and notice that is a line that passes through the first and the third quadrant, and it has this property that every point has the same x coordinate and y coordinate. So like notice 0, 0. If I just go right here in between and click, it's 1.05, 1.05. Any point I choose on the graph, 2, 2, has the same x value as it does y value. It doesn't really matter where we go, 4.81, 4.81, and so on. Even down here, that is true. All right, so that is the line y equals x. The next one that I want you to know by heart, and not sure, so I was trying to figure out how to do the square root on here, but I just went ahead and put x squared instead. All right, so x squared is also one of those I want you to memorize. This is a parabola, and it's an upward shaped parabola with its vertex at 0, 0. And the point where the two mirror images of one another come together is called the vertex. We'll be studying more about parabolas later, but right now we'll be doing some transformations that have to do with x squared. Now let's see if I can perhaps do the square root by raising it to the 1/2 power, because the 1/2 power is the square root. All right, well, notice that the square root function, and normally this would just say the square root of x, is like a rising hill, and it starts at 0, 0 and goes forever to the right. And you'll notice that there is no domain to the left of 0, and there's no range that is below 0 when we're dealing with our square root function. All right, then we also have x to the 3rd power. That looks like this. You'll notice that this thing is kind of centered at 0, 0, and this has the property that if we spun it 180 degrees, it would look like itself again. And we'll talk about that property a little bit later. It's what we call an odd function. But right now, you just need to know the shape of that graph. And then the last one, oh, no, there's 2 more I want you to know. And so the cube root function, and realize the 1/3 power is the same thing as the cube root. So I could have written this as the cube root with a little 3 for the cube root of x. But of course, Desmos doesn't seem to allow me to put a root in there. But let's notice it sort of looks a little bit like x cubed on its side. All right, it too has the property that if we swing it 180 degrees, it would land upon itself. All right, so this thing is also odd. And notice it's kind of centered at 0, 0 there. And then the last one is what we call the absolute value function. And I'm hoping I can do this one in Desmos. Yeah, there it is. All right, so the absolute value function, of course, has absolute values in its equation, and it looks like a V. And you'll notice that on this side of the V, every point has the same x and y value, but on this side, they're opposites of one another. So you'll have negative x values, but positive y values that are the same value, but opposite in sign. All right, that's our absolute value